Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to be talking about redox reactions, and I'm going to talk about what oxidation and reduction are and how you can determine whether or not you have a redox reaction and how you go about balancing a redox reaction. Alright, so the first thing you need to know is what redox actions are, or reactions are, or redox is short for oxidation and reduction. So reactions where electrons are transferred from one atom to another, those are redox reactions. So redox reactions are where you have an electron transferred from one atom to another. So we call them redox reactions for short. Atoms that lose the electrons are being oxidized. Atoms that gain the electrons are being reduced. And a couple of mnemonic devices that could help you remember this is one is oil rig. Oil is OIL, so you can remember that. That's going to be oxidation is loss. Oil, oxidation is loss of electrons. And rig is RIG, that's reduction is gain of electrons. Excuse me. So oil rig, oxidation is loss, reduction is gain. Oil rig. Another one is Leo-Ger, L-E-O, Leo the lion. Leo goes Ger, Leo the lion goes Ger, so Leo-Ger. Excuse me. Sorry. So Leo, loss of electrons is oxidation. L-E-O, loss of electrons is oxidation. Or Ger, gain of electrons is reduction. Ger, gain of electrons is reduction. So Leo-Ger. So oil rig or Leo-Ger are two ways that you can remember that oxidation is the loss of electrons and reduction is the gain of electrons. So what does this mean with regard to oxidation states? So oxidation states is a measure of what the charge would be on an atom if you were to allow the electrons and the bonds to be divided between the two atoms. If you are able to determine the oxidation states of each of the atoms in your substance, if an atom changes its oxidation state during the process of going from a reactant to a product, then that indicates that it's either being oxidized or it's being reduced. So if there's an increase in an oxidation state, well, that's going to be oxidation. So if you see an element that becomes more positive, then that means it's losing negative electrons. So that means it's being oxidized. If you see an element that is becoming less positive or becoming more negative, then that means it gained negative electrons, and so therefore it's being reduced. So here's an example where you are reacting sodium metal with chlorine gas to produce sodium chloride salt. So here you're studying with one reaction. So you got sodium going from 0 oxidation state to sodium being a +1 oxidation state. So it's becoming more positive, so therefore it lost an electron, so it's being oxidized. So sodium is being oxidized. So it's Na, and neutral sodium atom goes to positive sodium ion +1 electron. So that's the oxidation half reaction. These are what we call half reactions of what's going on. So we divide it into an oxidation reaction, So here we have the oxidation half reaction. Sodium is going from 0 to +1 charge oxidation state because it's losing 1 electron. And then chlorine is picking up 2 electrons and becomes 2 chloride ions. So chlorine here is going from a 0 oxidation state to a -1 oxidation state. And so chlorine is gaining the electrons. So Cl2 plus 2 electrons gives you 2 chloride ions. And this is the reduction half reaction of the redox reaction. So sodium is being oxidized, chlorine is being reduced. Okay, so I was talking about half reactions. So when you're dealing with redox reactions, you generally will divide them up into what are called half reactions. One of the half reactions is oxidation, the other half reaction is reduction. And the reason for this is because reduction and oxidation happen simultaneously together, because it's a transfer of electrons. One atom or substance is going to be losing the electrons because they are giving their electrons to another substance. Wherever those electrons are going, that substance is going to gain those electrons. So the substance that's transferring those electrons and giving those electrons away is being oxidized. The substance that's picking up those electrons is being reduced. So we can divide those into what are called half reactions. So we generally split the redox reaction into 2 separate half reactions. Reactions involving just oxidation or reduction, as we saw on the previous slide. So the oxidation half reaction has electrons as products because it's losing the products. So the products, the electrons are being formed. The reduction half reaction is writing those electrons as reactants because the electrons are being picked up. They're being gained by the substance. And so you can write this equation here. So the first thing you want to do when you're trying to figure out if it's a redox reaction is to write down the oxidation states of all the elements in all the compounds in your reactants and products. So your elements in their standard states are going to have a 0 oxidation state. So chlorine here is going to be 0 oxidation state. Iodide, the iodide ion, whenever you have a monatomic ion, that oxidation state is the same as its charge. So here we have an oxidation state of a -1. The chlorine, we have a 0 oxidation state. For hydrogen and oxygen, again, the way you do this, oxygen takes precedence. So you're going to give its normal oxidation state is going to be -2. So you give a -2 to oxygen, and then hydrogen gets what's left over. In this case, in order to balance the charge to 0, since water is a neutral molecule, and you have 2 hydrogens, each hydrogen has a +1 oxidation state, so that's going to balance out to 0 with the oxygen. Then you got chloride ion. So the chloride, again, a monatomic ion has the same charge has the same oxidation state as the charge. So here the chloride ion is a -1, so the oxidation state is a -1. And then we have IO3, which is a polyatomic ion. So the oxidation states for any neutral molecule or a polyatomic ion should add up to the charge of that molecule or ion. Here, the charge is -1, so the oxidation states of oxygen and iodine should add up to -1. So again, oxygen is going to take precedence over iodine. So you give oxygen its -2 oxidation state. And since you have 3 oxygens, that's going to give you a total -6. But the overall charge on the iodate ion is -1. So that means that the iodine here should have an oxidation state that's going to balance out the -6 in order to get you a -1. So that's only going to happen if the oxidation state of iodine is positive 5, because a positive 5 plus the negative 6 from the 3 oxygens is going to give you the negative 1 on your iodate ion. And then you have a plus charge on your hydrogen, and so again, a monatomic ion, the oxidation state is the same as the charge. So now that you've got your oxidation states here, now you can figure out what got oxidized and what got reduced. And so here you're just looking at changes in oxidation states. So here you see that chlorine goes from a 0 to a negative 1. So if you're going from 0 to negative 1, you're becoming more negative. That means that the chlorine atom got reduced. So gain of electrons. Reduction is gain of electrons. Here you're going from 0 to negative 1. That's a gain in negative charge, so it's gaining electrons. So the reduction half reaction would be Cl2 plus 2 electrons gives you 2 Cl minus. Okay. And then for the oxidation, if you look here, you could see that iodine started with a negative 1 oxidation state. And now here, it ends up with a positive 5. So it's becoming more positive, so it lost electrons. So you go from negative 1, iodide with a negative 1 on the reactant side, to iodate with a negative 1 on the product side, plus 6 electrons. Because you're going from a negative 1 to a positive 5. So you lost 6 electrons to go from negative 1 to positive 5. And so these are the two half reactions for this redox reaction. So that's how you can divide up your equation into two half reactions. And notice I'm only writing down the reactant and the product that's involved in this this particular half reaction. I'm not writing anything else except for the electrons that are there to balance. Same thing with the chlorine and the chloride. I'm only writing down the chlorine plus the 2 electrons gives me 2 chloride ions. That's all I need in order to balance the equation and the charge. Now you'll notice here that I don't have any oxygen. This is not balanced equation. We'll get to balancing in just a moment. But basically this is like your first step. You've divided everything into the two half reactions. The reactant for the oxidation, I'm just writing down the reactant, product, and electrons. For the reduction, I'm writing down reactant, electrons, product. That's it. The balancing will come in just a moment. So, speaking of which, let's talk about balancing. So we're going to use the half reaction method of balancing. So once you've divided your equation, your reaction into the reduction half reaction and the oxidation half reaction, now you can kind of balance the two half reactions separately, and then when you get those balanced, you can put them together. So this method is just a helpful way to balance complex redox reactions in solution. For simple ones, you can pretty much do them pretty easily by looking at it, but for more complex ones, this is a way that make it a lot easier. So the reaction again is broken down in its two half reactions, one for oxidation, one for reduction. Each of the half reactions is balanced individually for both mass and charge. So what they mean by balancing for mass is you balance the equation like you normally do. You make sure that each side of your half reaction has the same number and type of elements or atoms. Okay? Once you've got the mass on both sides, or the number of atoms on both sides balanced, then you balance the charge. The charge has to be balanced as well. So both sides have to have the same amount of charge, either plus or negative. And then once both of those half reactions are put together, you then once you balance those two half reactions, they're put together into an overall equation. And so here's the steps. So you're going to assign oxidation states, determine the element that's oxidized and reduced. write down the reduction half reactions, balance the mass of the half reactions, and then